Welcome to my channel. Simplify complex rational expression. With this whole picture, this part is identified as the numerator. Between this fractional bar and these expressions below are considered as the overall denominator, because later we will be simplifying each part. Let's start. Let me erase this first. When we look at this, they are similar fractions because the common denominator are there, or the denominators are the same. So just simply copy this common expression, which is n plus 5. Then copy also these expressions above. So n squared plus 5n minus 4n. Okay, let's proceed with this next part. Okay. Remember, over, this is fractional. So identifying these expressions, we also have common denominator. So just like what we did in the first part, which is having common denominator or the same denominators, it also appears in the next expression. So copy n minus 5 times n plus 5. Or you can exchange them. You can write n plus 5 before n minus 5. What is important there is there's no violation. And even if it's interchange, you will still end up with the correct answer. Okay, let's go back. This is common. I only copy this one because they're the same. Then copy also these expressions above. Okay, n minus 5 plus n plus 5. Let me put another fractional bar here. Then combine the alike term. So n squared, 5n minus 4n are alike terms. They are the same. So let's combine them. Okay, so that's 1n, or just simply write n over copy the existing denominator, n plus 5. Then for the next, n plus n, that's 2n. The negative 5 plus 5 eliminates because that's 0. Okay. Let's continue. Copy these expressions. N minus 5 n plus 5. Sometimes I utter the word times because this close and open parenthesis symbol signifies multiplication. Okay, let me proceed. Let me choose another color. Okay. Let me occupy this space. Since we are done combining the alike terms, okay, let's apply the basic arithmetic. When you divide a fraction by another fraction, you have to copy this numerator, okay? Copy the numerator over the denominator, then divided by numerator over denominator. But just flip, okay? Flip this. Meaning, this place is now transferred in the numerator's place. So this now becomes the numerator, n minus 5 n plus 5 over 2n. Then, let's see of any expressions that can be divisible by itself so that we can cancel. Okay? So we have n plus 5 divided by n plus 5. Oh, let's cancel. Okay. Let's now proceed. Copy the remaining expressions. N squared plus n times n minus 5 over 2n. Okay. Let's expand this. N squared plus n times n minus 5. So, negative 5n, negative 5n squared. Then, positive n squared. Then, plus n cubed. Okay. N cubed plus n squared minus 5n squared minus 5n. Okay. Let's combine the alike terms. Let's copy it. N cubed. Then this one, n squared. So this now becomes negative 4n squared minus 5n. Okay, meaning this is now the expanded form. So let me copy. N cubed minus 4n squared minus 5n over 2n. And then, since they have common factor, which is n, so let's factorize this. So the common there is n, okay? And then x squared minus 4n minus 5 over 2n. Okay, we have common. The common there is n is divisible by itself, meaning you can cancel n by another n. So 2 is now the remaining expression. 2 is now the constant that is left. Okay. Do you know that this n squared minus 4n minus 5 is factorable? Okay, let us see. N, that is minus 5 times n plus 1 over 2. Let us see if we expand this, the result would be this one, this trinomial, first, second, third term. So let's check. By multiplying n minus 5 times n plus 1. Negative 5. And then n, negative 5n, and then n squared. So n squared minus 4n minus 5. Let me see. Oh, it's correct. Okay, exactly the same. Meaning, this binomials, these expressions, is already the factors of this trinomial over 2. That means this is now our final answer. I hope that you understand my explanation again. Thank you so much.